In this video, we're going to start the KutaSoftware Infinite PreAlgebra free worksheet, simplifying variable expressions. Now, for numbers 1 through 22, we're going to be simplifying each expression. And what that means is we're just going to combine all of our like terms in order to simplify. And in some cases, we'll need to distribute, but we'll deal with that when we get there. Let's jump into number 1. In number 1, we have a negative 3p plus a 6p. Now, you may want to rewrite this as 6p plus a negative 3p. And if I rewrite it like this, that's the same as 6p plus a negative, subtract the positive. So you just have to say, if I have 6 p's and I'm subtracting 3 of those p's, because I have 1 p in each of my terms, I can just subtract the numbers, leaving my p. So 6p minus 3p, 6 minus 3 is 3, so 6p minus 3p will be 3p. So 3p is my simplified expression in number 1. And what an expression is, in case you need a refresher, an expression is just different terms with operations where they're not equivalent to something else. If this had an equation sign, like negative 3p plus 6p equals some number 5, then that would be an equation. But because it does not have this equals part, it is just an expression. So let's move on to our expression in number 2. In number 2, we have b minus 3 plus 6 minus 2b. Now we need to try to simplify by combining like terms. So the terms that are like, we have this 3 and 6, and we have our b and our 2b, because this is kind of like 1b. So if we look at this, we have 1b, and we're subtracting 2b, because this subtraction goes with this 2b. So if I have b minus 2b, that's going to leave me with a negative 1b. And then I'm still subtracting 3 and adding 6. Now, negative 1b, we can simply just write a negative b, because negative 1b is the same as negative b. Now I have to deal with my negative 3 plus 6. Because this 3 is subtracted, I'm going to consider it as negative. So if we have a minus 3 and then we're adding 6 to that, that's going to result in a positive 3. So negative b plus 3 is my solution in number 2. And if it helps, rewrite all of the subtraction as adding a negative. So I could have rewrote this as b plus a negative 3 plus 6 plus a negative 2b. Positive negative, where the negative is greater, that's going to result in a negative b. Negative 3 plus 6 is going to be a positive 3. So that's just another way to look at it if you want to compartmentalize your numbers in that way. Let's move on to number 3. In number 3, we have 7x minus x. This is like saying 7x minus 1x. If we have 7 x's and we're taking away one of those x's, or using this terminology, if we have 7 apples and we're taking away 1 apple, we'll have 6 apples left. So if we have 7 x's minus 1x, we'll have 6 x's left. So 6x is our solution in number 3. Let's move on to number 4. In number 4, we have 7p minus 10p. I have a p to the first here and a p to the first here. P to the first meaning p to the power of 1. So these are like terms, so I can simply subtract, leaving the variable raised to the same power. So 7p minus 10p, 7 minus 10 results in a negative 3, but 7p minus 10p results in a negative 3p. So negative 3p is my solution in number 4. In number 5, I have negative 10b plus 6b. So if I'm starting with negative 10 of something and I'm adding 6, that's going to result in a negative 4 of that thing. So if I have negative 10v plus 6b, that's going to be negative 4v. So negative 4v is my solution in number 5. And if you wanted to rewrite this, you could have rewrote this as 6v plus a negative 10v because addition is commutative, and then 6v minus 10v is negative 4v. Let's move on to number 6. In number 6, we have negative 9r plus 10r. Let's go ahead and rewrite for fun. So we have 10r plus a negative 9r, which 10r plus negative 9r is the same as 10r minus 9r. So if I have 10 r's and I'm taking away 9 of those r's, I'm going to be left with 1 r, but when we have a coefficient of 1, we just leave it as the variable r. So r is our solution in number 6. In number 7, I have 9 plus 5r minus 9r. 9 is the only number by itself. So 9 is going to still be there when we simplify. However, I have a 5r and a 9r. I can combine those. So I'm going to have 9 plus 5r minus 9r is going to be a negative 4r, which plus a negative we'll write as subtracting the positive. 9 minus 4r, that's our solution in number 7. In number 8, 1 and 10 are just numbers, and the 3v is all by itself. So let's go ahead and simplify by combining our constants together, and then the negative 3v or 3v's will remain all by itself, and it will still be subtracted. So 1 plus 10 gives us 11, and we'll subtract that 3v. 11 minus 3v is our solution in number 8. In number 9, 5n plus 9n. If we have 5 of something and we add 9 of it, that's going to result in 14 of that thing. So 5 apples plus 9 apples equals 14 apples, or 5 n's plus 9 n's results in 14n. Now in number 10, we have 4b, but nothing else with b, so 4b will remain as is, and then we have 6 minus 4. So I'll have 4b plus 6 minus 4, which is 2. 4b plus 2 is my solution in number 10. Now in number 11, I have 35n, which is my only number with an n, and then I'm subtracting 1 and then adding 46. So I'll have 35n remaining. Now I'm just going to combine subtracting 1 and adding 46. So if I'm taking away 1, that will be a negative 1. But then I'm adding 46 to that, so that's going to be like 46 minus 1. And 46 minus 1 is going to be a positive 45. So that's going to be 35n plus 45. That's my solution in number 11. Now in number 12, I have negative 33v minus 49v. This has a v to the first, and this has a v to the first. So because I have my variable of the same power, I can combine these terms. Negative 33 minus a 49 is going to be a negative 82. So if I have negative 33v minus 49v, that's going to result in a negative 82v. So negative 82v is my solution in number 12. In number 13, 30n plus 8n, 30 of something plus 8 of that same thing is going to be 38 of that same variable, so 38n. In number 14, we have 7x plus 31x. 7x plus 31x is going to be 38x. In number 15, it's a little bit longer, but remember, we're still going to combine like terms in order to simplify. So we have a 10x and a negative 38x because this 38x is subtracted. And we have a 36 and a negative 47, or 36 minus a 47. So if we do 10x and we subtract 38x, that's going to be negative 28x. And then we'll add that to 36 minus 47, which is going to be a negative 11. but as opposed to adding a negative, I'll rewrite this as subtracting a positive. So I'll have negative 28x minus 11 as my solution in number 15. So 10x plus 36 minus 38x minus 47 is equivalent to negative 28x minus 11. My answer is just the simplified expression. Now, in number 16, this is the first one in which we're going to have to distribute. Because we have these parentheses here, order of operations says we have to do 7 minus n first. But we don't know what n is, so we don't know what this result's going to be. So we're going to use our distributive property, which says we can multiply in negative 2 to each of our terms in order to get rid of those parentheses. So I'm going to have negative 2 times 7. I'll be subtracting that from negative 2 times n, and then I'll add 4. So you can see negative 2 times 7 is going to be negative 14, and we'll subtract negative 2 times n, which is a negative 2n, and then I'll add 4. Now I have some like terms. Negative 14 and 4 I'll be able to combine, and then I'll simply rewrite subtracting a negative 2n. So negative 14 plus 4 results in a negative 10, and subtracting a negative is the same as adding a positive, so that'll be negative 10 plus 2n. So you can see negative 10 plus 2n looks a lot neater and a lot simpler than negative 2 times the quantity 7 minus n plus 4. That's what simplifying is all about, is to make our problems easier. So I recommend always simplifying at the start. Now, let's move on to number 17. In number 17, we have, again, a parenthesis, and because we cannot combine negative 5b with 7, because we don't know what b is, we're going to distribute this negative 8. So negative 8 will get multiplied to negative 5b, and then negative 8 will also get multiplied to 7 with addition in between. In number 16, we had subtraction in between, but in number 17, we have addition in between. So negative 8 will get multiplied to a negative 5b, and then I'm going to be adding, because I have addition in between, I'll add that to negative 8 times 7, and then we'll add that 5b on at the end. So doing out some more math, negative 8 times a negative 5, negative times a negative is a positive, that'll be a positive 40b. And I'll be adding that to negative 8 times 7, that's a negative 56, and then I'll add that to 5b. So combining my like terms, I have 40b and 5b, so combining those together, 40b plus 5b is going to be 45b, and then we'll subtract, as opposed to adding a negative, I'll just subtract the positive, 56. 45b minus 56 is my solution in number 17. Now in number 18, I'm going to have to distribute, and it may look a little interesting because I don't have a number out here that I need to distribute, but because I'm subtracting this quantity, that's kind of like subtracting 1 times the quantity, right? And if I'm subtracting a 1 minus 6p, I'm subtracting the 1, and I'm also subtracting the subtraction of 6p. So I'm kind of going to just distribute this minus sign in there, or you can think of it as distributing in a negative 1. So I'll have negative 4p, and then I'll subtract my 1, and I'll subtract my negative 6p. So you can see, really the only thing that gets changed up is subtracting this negative. That's going to be the same as adding a positive. So I'll have negative 4p minus 1 plus a positive 6p. And that's just going to make our lives a little bit easier when combining negative 4p and 6p. Negative 4p plus 6p, because now we have like terms. Negative 4 plus 6 is going to result in a positive 2. So negative 4p plus 6p is going to be 2p. And then I'm still subtracting 1. 2p minus 1 is our solution in number 18. Now, for some reason, I was having a little bit of trouble getting 19 to show up, so I've just rewrote the problem. But number 19 says 4 minus 5 times negative 4n plus 3. We can't combine negative 4n and 3 together within those parentheses, and parentheses comes first in order of operations. So instead, I'm going to distribute this 5 to each of them. And remember, this 5 is subtracted. So I'll go ahead and distribute a negative 5 to both of these. So we'll get 4 minus 5 times negative 4n is going to be negative 20n, and then I'm going to be adding that to 15. However, we're subtracting this entire quantity, so you can almost think of it as distributing in a negative 5, because 4, I'm going to be subtracting 5 times negative 4n, and I'm going to be subtracting 5 times 3. So I'll do negative 5 times 3. 4 minus a negative is going to be 4 plus a positive, so 4 plus 20n plus negative 5 times 3 is going to be minus a positive 15. 4 minus 15 results in a negative 11, so I'll have 20n minus 11. That's my solution in number 19. You could also write this as negative 11 plus 20n. The order in which you write addition doesn't matter, and you can think of subtracting a positive as adding a negative. So I could also have negative 11 plus 20n. Either way is the correct simplified expression. Now for number 20, I have parentheses where I have k minus 8. I cannot do that because I don't know what k is. So I'm going to need to distribute negative 7 into both of those terms, remembering that there's subtraction in between. So if I have negative 7 times k, I'll then be subtracting negative 7 times 8, and finally adding 2k. Now to simplify down, negative 7 times k is a negative 7k, and I'll be subtracting negative 7 times 8 is negative 56, and then I'll add 2k. Negative 7k plus 2k is going to be a negative 5k. So I combined my like terms here. However, I'm still subtracting a negative 56. But subtracting a negative is the same as adding a positive. So I'll be adding 56. Negative 5k plus 56 is our solution for number 20. Now, on to the second to last number on this worksheet. And here's a quick friendly reminder, if you haven't done so already, click that like button, and while you're doing that, subscribe to my channel. But for now, continuing on, we'll have 1 plus, I'm going to need to distribute this 7 to the 1 and the 3b. And I'm adding this so my sign in the middle won't change. So 7 times 1 minus 7 times 3b. So I'll have 1 plus 7 times 1, which is 7, minus 7 times 3 times b is going to be 21b. 1 plus 7 is 8, so I'll have 8 minus 21b for my solution in number 21. And again, you could have also written this as negative 21b plus 8. That's equivalent to 8 minus 21b. And lastly, number 22. In number 22, 3 minus 8 times the quantity 7 minus 5n. Now, because I have subtraction out here, I'm subtracting this entire quantity. So within here, we're going to change it to a positive when we distribute that 8. Because it's kind of like distributing a negative 8. So 8 will go with 7 and 8 will go with 5n. So think about this as negative 8 times 7, which will give us a negative 56, which will still be subtracting a 56. And then negative 8 times 5n will be plus a 40n. Because if we're subtracting 8 times 5n, we're subtracting 8 times 40n. But that 40n is already subtracted, so subtracting a negative is the same as adding a positive. So let's work through this. We'll have 3 minus 8 times 7, which is 56, minus 8 times 5n, but that 8 times 5n is already subtracted, so minus a negative will be adding a positive 40 in. Now all I have to do is 3 minus 56, which is a negative 53, and then I'll add that to 40 in. That's my solution in number 22, which you could also write as 40 in minus 53. But with that, we wrap up the last problem on this simplifying variable expressions worksheet. If you have any questions, leave them in the comments below. And if you want to support me, become a patron. But as always, don't forget to like, subscribe, and share. Thanks again, and happy learning!